You shove a massive load of freshly washed, heavy cotton towels into your sleek, titanium-finished laundry pedestal, punch a glowing digital button on a glass panel, and walk away. 90 minutes later, the chime plays a cheerful, high-definition little melody. You pull open the tinted glass door and are immediately hit in the face with the unmistakable odor of hot, sour mildew mixed with the dense atmosphere of a swamp. The towels are a lukewarm, heavy, soggy mess. You toss them back in for cycle number 2, then you come back and run cycle number 3, standing there watching your electric meter spin fast enough to generate lift. 20 years ago, a crude white metal box blasted moisture into the atmosphere with sheer brute force and handed you bone-dry denim in 45 minutes flat. Today, you drop $1,200 on a networked machine with a capacitive touchscreen that fundamentally struggles to evaporate basic tap water. The engineering flaw driving this frustration is fundamentally simple, yet completely intentional. This is a deliberate thermodynamic downgrade designed to satisfy strict regulatory energy quotas while quietly accelerating the physical death of the machine. The heat is being intentionally choked out. We are going to rip apart the 3 engineered choke points, turning your laundry room into a damp sauna. We will expose the microscopic thermal throttling padding, corporate service contracts, detail the exact digital extortion loop draining your wallet, and reveal the heavy iron analog machines veteran repairmen actually install in their own homes. Let us rip the marketing mask off. Look at the showroom floor, where the sales pitch focuses heavily on whisper quiet operation, vibration reduction, and sleek, minimalist aesthetics. To achieve that acoustic silence and tight clearance, the mechanical engineers completely redesigned the primary airflow pathway. Instead of a massive, straight, high-velocity metal exhaust pipe that moves air efficiently, your new unit features a convoluted, 90-degree internal plastic maze. They replaced the rigid, heavy-duty, galvanized metal blower wheels with flexible, injection-molded plastic fans. Watch what happens when cheap plastics meet sustained heat. The core mechanics of moisture removal demand massive, unrestricted cubic feet per minute of air movement to carry vapor away from wet fabric. But inside this plastic labyrinth, the restricted airflow creates a massive thermal backlog. The ambient temperature inside the lower cabinet skyrockets beyond the material limits of the components. The cheap plastic fan blades begin to soften, slowly losing their structural pitch under the intense heat. As the blades flatten out and warp, the exhaust velocity out the back of your house drops by 60%. The heavy, moisture-laden air stalls inside the drum. Lint stops blowing out the exhaust pipe and instead drops out of suspension, mixing with the trapped steam to form a dense, damp concrete paste that coats the entire internal housing. The airflow dies inside the cabinet. You will eventually pull the lint trap and smell a thick, rotting musk, while hearing a violent rhythmic thud as the off-balance, warped blower wheel hammers against its own casing. The financial damage hits the mid-hundreds easily for a complete cabinet teardown, an environmental cleanup of the internal housing, and a replacement blower assembly. The very first thing an independent technician does on a service call is test the exhaust velocity at the exterior vent, knowing that plastic wheel has already failed. Silence was purchased with early failure. Here is where the boardroom math quietly turns into a wallet extraction event. You bought the machine because of the brightly colored sticker declaring Energy Star certified smart moisture sensing. The showroom promise is that the machine knows exactly when your clothes are perfectly dry, supposedly saving the planet and lowering your monthly utility bill. The dark reality is a system we call the eco-sensor Stranglehold. Look inside the front lip of the drum, right where the clothes tumble. You will see 2 tiny, curved metal strips. These are basic conductivity sensors. The physics of evaporation cannot be cheated by a microchip. Every time you wash clothes with liquid fabric softener or toss in a waxy dryer sheet, an invisible, microscopic film transfers directly to those exact metal strips. This layer acts as a perfect electrical insulator. The soaking wet clothes brush continuously against the waxy sensors, but the conductivity circuit cannot complete the loop. The blinded sensors immediately send a false dry signal back to the main logic board. The board, strictly programmed by the eco-sensor Stranglehold mandates, aggressively cuts power to the heating element after just 12 minutes. It leaves the drum tumbling cold, useless air over wet fabric for another hour. the machine lies to the motherboard. The result is pulling out a pair of thick jeans and feeling perfectly dry material on the lower legs, but freezing, heavy, wet waistbands that take another 2 full cycles to fix. Did you really think a Wi-Fi antenna would dry your clothes faster? You end up throwing away more than the cost of a budget machine, just replacing expensive proprietary control boards, chasing a ghost electrical issue that is actually just a microscopic layer of wax on a cheap piece of tin. If you look inside the tool bag of an independent technician, you will find a bypass jumper wire used exclusively to override these modern digital safety systems, just to see if the heater still physically works. The computer is actively fighting you. But let us follow the airflow into the belly of the beast. The final choke point is hidden entirely behind the showroom promise of massive, ultra-large drum capacity. You think bigger is inherently better. To make room for that massive internal cavern while keeping the same standard exterior dimensions, the engineers had to compress the vital heating element assembly into a dangerously tight sheet metal box. They completely downgraded the rugged, thick-coiled nichrome wire of the past to paper-thin gauge alloys that fundamentally cannot handle poor ventilation. This is fundamentally an engineering crime disguised as environmental progress. Because the plastic blower wheel from the first choke point is warped and the system airflow is severely restricted, the internal temperature of that compressed heater box spikes well beyond safe operating limits. The paper-thin wire physically blisters under the intense thermal load. The cheap metal expands, sags, becomes brittle, and eventually snaps, grounding out violently against the metal chassis of the machine. The metal snaps under thermal load. You will hear a brief, sharp, metallic pop from behind the console, followed instantly by the dark, burnt electronics odor of scorched ozone lingering inside the steel drum. This is what happens when you let software engineers design heavy machinery. The heating element itself might be a relatively inexpensive part, but it is buried so maliciously deep within the sharp metal chassis that it requires a complete hour-long structural teardown just to extract it, leaving you staring at an exorbitant labor invoice. We absolutely refuse to install these massive capacity drums in our own homes because we know exactly how fragile that thermal box truly is. The heat completely kills the host. Now step into the service call trap. When this predictable cascading failure finally halts your laundry routine, the corporate extraction machine kicks into high gear. First, you dial the toll-free warranty number and are forced to wait 3 agonizing weeks just for a third-party contractor to show up at your door. Second, you pay an automatic, non-refundable diagnostic fee just for a kid with a Bluetooth tablet to randomly guess that the machine needs a new main computer. Finally, you wait 2 solid months for a back-ordered, proprietary control module that fixes absolutely nothing because the actual root cause was always a warped 40-cent fan blade starving the entire system of air. The machine is designed to be mathematically unrepairable by the average owner. Any mechanic who digs through these sheet metal coffins knows the real story. Ask any guy who spends his life pulling lint-packed blower wheels out of basement utility rooms, and he will tell you the sheet metal keeps getting thinner while the repair bills keep getting fatter. You do not have to participate in this rolling catastrophe. You can walk into a big box store and completely sidestep the modern extraction loop. Here is your blueprint. Find the absolute cheapest, ugliest base model on the floor. Demand heavy analog mechanical knobs that physically click. Ensure a straight pipe internal exhaust run out the back. Reject all capacitive touch glass interface panels. Verify the lint screen housing is thick, rigid metal. Refuse any machine boasting wireless smartphone connectivity. Stop financing your own frustration by purchasing fragile appliances disguised as luxury electronics. True mechanical reliability is heavy, loud, and completely devoid of a microchip. Demand machines built for thermodynamic violence, not digital convenience. If you are tired of the endless cycle of corporate appliance extortion and want the unvarnished truth directly from the field, subscribe to the channel. Never let the eco-sensor Stranglehold dictate how many hours you spend doing basic chores.